Hello everyone, and welcome to the IFST webinar, Hygienic Design, what it is, why it's important, and who can help, organised by the IFST Food Processing Special Interest Group. My name is Deb Smith. I'm the Global Hygiene Specialist at VCAN, a Danish-based manufacturer of cleaning tools and utensils to the food industry. I provide their food safety advice and training. I'm a qualified microbiologist and food scientist with nearly 40 years of food safety and research experience. As well as being a fellow of the IFST, events coordinator for the IFST Food Processing SIG, and sitting on the IFST Scientific Committee, I'm an active committee member of the EHEDG UK and Ireland regional section, hence bringing these two organisations together in this webinar. The Food Processing SIG have pulled this webinar together because we believe it will provide some essential information to IFST members. Hygienic design, which is basically designing something that is easy to clean, is a key factor in the maintenance of food safety and quality. But despite being championed in Europe by the European Hygienic Engineering Design Group for over 25 years, awareness of hygienic design principles and their application in the food industry is still limited. We hope that this webinar will raise awareness of what hygienic design is and why it's important, who EHEDG are and how they can help, what the hygienic design requirements of GFSI's Scope J1 and J2 are and how they can be achieved, and what the requirements are for hygienic design in BRCGS Issue 9. The IFST Food Processing SIG are also actively sourcing potential resources to signpost in a new IFST Food Processing Knowledge Hub. So if any of you have any suggestions on what could be included, please send these to info@ifst.org. Next slide, please. This webinar is being recorded and will be uploaded onto the IFST Webinar Hub. Please feel free to make comments and ask questions throughout the webinar using the Q&A button at the bottom of your screen. You can also upvote other people's questions by clicking the like button next to their question. There will be a Q&A session after the presentation where we will be able to respond to as many of the questions posed as possible. We are very fortunate today to have three expert presenters for this webinar. Eric Partington, Chair of the EHEDG UK and Ireland Regional Section. Eric will introduce EHEDG and explain the principles of hygienic design and why they are important. Professor John Holah, Chair of the GFSI Technical Working Group, convened to develop the benchmark scopes related to hygienic design. He will explain how these represent a step change in the application of hygienic design within the food industry from farm to fork. And Nigel Blitz, part of the Food Safety Management System Services team at Camden BRI. As such, he has been closely involved in the development of BRCGS version 9 and will detail the hygienic design related requirements that can now be found within it. For more information on our speakers' biographies, please look at the IFST website. So with that, I will now hand over to you, Eric.
Good morning, everyone. The question is, what is EHEDG? The European Hygienic Engineering and Design Group, EHEDG, is, if you like, a worldwide knowledge community of equipment manufacturers and food processing industries, public health authorities and legislators. It has about 1,400, a little bit more than that, a little bit more than 1,400 members, and they're all specialists in food safety, microbiology, food research and development, and or engineering. And they work together to increase the effectiveness of cleaning techniques and to advance the science of food safety. EHEDG's membership now includes over 600 companies, universities and institutes from 55 different countries, in 32 of which EHEDG is represented by a regional section, which disseminates knowledge locally. We're talking about food producers such as Unilever, Mondelez, Stork, Nestle, engineering companies like GEA, KHS, Anderson Hauser, research facilities such as Camden BRI in the UK, IENIA in Spain, Purdue University in the USA, and suppliers of products and services such as VCAN, Kersia Group, and Diversi. But how did EHEDG come about? Well, in the late 1980s, Unilever in the Netherlands was experiencing a disturbing number of food contamination problems, which they traced directly to production equipment not being completely clean before the processing of a new batch of food began. And they were not alone. The jungle drums eventually revealed that a number of their competitors throughout Europe were experiencing the same problems and gradually coming to the same conclusion, that despite their best intentions, their cleaning procedures were simply not up to the job of sanitizing the plant that they were using. In conjunction with those competitors, Unilever set up a research project to look at how good design could both improve the equipment's resistance to contamination and improve its cleanability. And so in 1989, EHEDG was born. Within 5 years, it had prepared 13 technical guidelines, all of which were written by volunteer experts in the relevant fields. These addressed subjects as diverse as welding stainless steel to meet hygienic requirements, and the hygienic design of equipment for open processing. Today, EHEDG has published and keeps up to date more than 50 guidelines. Okay, but what constitutes hygienic engineering? It's almost easier to say what constitutes unhygienic engineering. Take these examples from guideline number 8, Hygienic Design Principles. If your product is flowing through pipe A, which has to bypass pipe B, and it does so by ducking underneath it, how are you going to flush out all the food products after one production run? And just as importantly, how are you going to flush out the CIP chemicals before the next run? The answer is only a simple rearrangement of the pipework. Centrifugal pumps are often mounted in what seems to be the most obvious and stable orientation, horizontally. But this can leave a sump which cannot easily be drained of either product or detergent. A fairly simple reorientation makes the pump drainable and therefore cleanable. If the exhaust from a tank is above the level of its base, will it drain completely? Or will what is left at the bottom mix in with the next batch of product? These are examples of the remnants of one production run, perhaps deteriorating in quality from being exposed to the air, being able to pass on infection to the next batch of food. But the UK Statutory Instrument 1597/2008 specifically stipulates that it must be possible for liquids deriving from foodstuffs, as well as from cleaning, disinfecting, and rinsing fluids, to be completely discharged from the machinery. So hygienic engineering is actually the law. Just as dangerous, however, is the buildup of process soils and the formation of biofilms inside the equipment. Bacteria are small, typically only about 1/50th of the diameter of a human hair, and they can hide in the tiniest of crevices or behind the smallest of ledges, or even in scratches on the internal surfaces of food processing equipment. From there, they can be difficult to scavenge, even with hot, detergented, turbulent cleaning agents. And this means that precision engineering is needed to combat the advance of these tiny but harmful microorganisms. So surface finish is critical. EHEDG recommends that large surface areas in contact with food have a smoothness of 0.8 microns RA or better. To put this into context, a commercial 2B surface finish on stainless steel has a smoothness of about 0.4 microns RA, offering much lower peaks and shallower troughs for bacteria to try to hide in. But construction is critical too. Where two lengths of pipe cannot be welded together because during maintenance they need to be separated, a flange joint may be the only answer. But here the danger is that there will always inevitably be a crevice, a fine crevice between the two flanges, even if their faces have been milled smooth. A synthetic seal is the usual solution to precluding crevices, but its positioning within the flange joint must be carefully controlled. If it is recessed back from the product flow, as on the left, it will still leave an uncleanable crevice. If it protrudes into the product flow, as on the right, it offers a shelf where bacteria can accumulate and be difficult to remove. Designing the perfect flange joint involves knowing the behavior of both the metal, usually stainless steel, and the elastomer of the seal, particularly their coefficients of thermal expansion, so that at the correct operating temperature, the surface of the seal is just level with the bores of the pipes. Of course, the pipes themselves must be aligned perfectly so that there is no step to catch soils, product soils. And here a design feature such as a radial guiding shoulder can help to align the two halves. Design is also important. Here, the drop in temperature of a synthetic seal causes it to contract. From this position to that position, as the temperature falls, this seal contracts and sucks in microorganisms from the product area. When the equipment warms up again, however, those microorganisms can be expelled back out into the next batch of product. EHEDG has established a series of test procedures to evaluate the cleanability of equipment. These can be carried out in one of the 8 EHEDG authorized laboratories in Europe, Taiwan, and the USA. To date, these test houses have together certificated about 450 pieces of equipment as being hygienically designed. They're all listed on the EHEDG website. In his PhD thesis in 2010, Andreas Dorner at Kraft in Austria compared the cleanability of 2 sections of plant. He studied a module which comprised poorly designed, badly installed valves and probes, and he determined the time for which it was necessary to apply the recommended cleaning procedure to ensure sanitization. Then he compared it, oh dear, thank you. Then he compared it with a best practice equivalent and found that it required only 1/4 of the cleaning time. Over a very short period of time in service, the savings in detergent, the water to add to it, the energy to heat them, the effluent burden, and the downtime required for CIP more than justified the 20% premium on the purchase cost of the equipment. And there's a lot of specialist help out there, much of it just for the asking. EHEDG guidelines are available to non-members for as little as £100 each. Have a look at the EHEDG website, ehedg.org, and search for guidelines. Maybe start with guideline document number 8, Hygienic Design Principles. It's the granddaddy of all the guidelines, and EHEDG considers it so fundamental to food safety that it offers it for download in its entirety, free of charge. You have a regional section of EHEDG right here in the UK. Maybe they can help you with your problem, or maybe you can help them by offering your expertise to others. And the Nickel Institute and the British Stainless Steel Association can offer advice on the selection of materials to meet any given operating conditions. The purpose of all this food safety legislation and the reason for the very existence of EHEDG is quite straightforward. It's to protect the customer. And in my view, that single objective should drive the whole cooperative process of specifying, designing and operating food processing equipment. Thank you. I'll now hand over to John.
Hi, good morning, everybody. Thank you, Deb, IFST, for asking me to present, and delighted to do so. And what I'm going to talk to today is a little bit about hygienic design risk management. To go back to basics, the way that we operate in terms of GFSI sanctioned audit schemes is that GFSI at the top of this pyramid set benchmarking requirements. Those benchmarking requirements are then picked up by the certificate program owners who create such as BRC, the current version 9, or IFS, FSSC 22000, etc. Auditing bodies like Lloyd's Register or SGS are then able to use the CPO schemes, the BRC schemes, to audit food manufacturers. And benchmarking requirements are across the board. They're available from farm through feed, the food manufacturers, converters, all the way to retail. What has happened recently is that in the 2020 benchmarking scope, 2 additional scopes were created called J1 and J2, and they provide a benchmarking standard to which CPOs can develop a potential audit scheme for the manufacturers of equipment or the constructors of buildings, that's J1, or an updated version of what was originally hygienic design requirements in the existing scopes, J2, which can voluntarily be applied to the current CPO standards. One of which now we have seen with the adoption of some of the principles of J2 into BRC version 9, which Nigel is going to talk about later. So what is hygienic design risk assessment and management? What are the issues? Primarily, it's a language basis, and there is a legal requirement for all food manufacturers through EC 853 to use HACCP as their risk management tool. But equally, there is a requirement under the Machinery Directive to use ISO 12100 for equipment manufacturers, to use that as a basis of risk management. So there are difficulties in language here, and the EHEDG have got a working group which are beginning to try and build the principles of J1 and J2 into a risk management cycle. And it starts off with describing the intended use of the building or the equipment, and I'm going to use equipment throughout the presentation, but it is both, to describe what the use of that piece of equipment is. And then there is a hazard analysis of that piece of equipment based on that intended risk use, to identify the hazards and the potential risks for those hazards. Then a mitigation stage through hygienic design. Can we get rid of the risk of most of those hazards by designing the equipment possibly? And then can we manufacture that piece of equipment without adding any additional hazards? Can we install that piece of equipment without adding any additional hazards? And then ultimately, the residual hazards, can we manage them in the food manufacturing environment through a maintenance program and a cleaning and disinfection program? And then periodically ask the question, has anything changed? So is our legacy equipment that has now been in place still fit for purpose for its intended use? That is going to require a change in the way that we perceive hygienic design in food manufacturing. And perhaps the most important one is the adoption of a multidisciplinary team. And for the first time, this is asking us to get together all of the stakeholders that use that machine, order the machine, specify it, clean it, maintain it, to come together, help create a specification for the purpose of the hygienic aspects of that machine to create then something that everybody is comfortable with. So the disciplines are on the left-hand side of the screen, and it really is everybody who's a stakeholder in the use of that piece of equipment. The knowledge basis that team might have is on the right-hand side of the slide, and maybe the first part of the development of this team is looking at hygienic design training to help to undertake the tasks that the team should put together. So on the top right-hand side, we've got external internal communications. This is the first part of the concept of adopting J2, and it's communications. And this is internal communications. Let's talk about design equipment more so internally. Intended use is looking at what that equipment might be used for over the next 5 years or so. What products will be processed, what processes is there, who are the final consumer of the products produced, and what are the cleaning conditions, dry, wet, etc. And much of that information will be available from the HACCP plan. Then there's a second part of that, which will be determining a little bit more what the equipment will do. What is its purpose? Is it a mixer, a slicer, etc.? What operating conditions will it operate in? Is it going to be in low risk or high risk? And there's quite a lot of engineering considerations as well that are needed as part of describing its intended use. We then do a hygienic design risk assessment to try and understand what the hazards are and what their risk is. This is primarily HACCP based, but is subtly different. The hazards will come from the HACCP plan, but whereas the HACCP plan is asking the likelihood and the severity of the risk of the hazard to the final consumer, this is asking two subtly quite different ones. The likelihood of occurrence of the hazard in the product and the likelihood of the presence of the hazard at the point of consumption. So the occurrence is the hazard likely to be present, and on the top there are a number of requirements that might control that. And then on the left-hand side is if the hazard gets into the product at the point of use of the machine, is there any subsequent stages in the production process that might remove the hazard, sorting, washing, sieving, etc. So it's looking at how the hazard could be present at the time of manufacturing the machine, and then how could we control some of these, and whether there is any control processes afterwards that would remove that hazard from the product prior to it being consumed. Following the intended use and following a hygienic design risk assessment, we can begin to put together a user requirement specification for the purchase of a piece of equipment. EHEDG is helping in this sense of templates. So the top left is a potential template which describes the hazards on the top, and the classic chemical, biological, physical hazards as applied to HACCP, but also some issues that hygienic design also controls, but aren't necessarily hazards. So processing issues, is it a heat exchanger that fouls after a certain time? Organoleptic issues, are we concerned about the presence of a previous batch into the subsequent batch, and how do we control those? And maybe brand protection issues. If the residues from the previous batch contain meat and we're doing a vegetarian dish, or if it's related to a meat species, pork in beef, or the reverse, etc. And a little bit about how the hazard could possibly penetrate into the equipment and then the product, and whether it could accumulate, or whether if it was bacteria or pests, whether it could grow. We then have an assessment of the likelihood of the occurrence and the likelihood of the presence at the point of consumption. And we've got green, orange and red as risk assessments. And this one is showing that there may be problems with cleaning agents, but those will probably be taken away by processing steps and not be an issue. Lubricants, if we had poor lubricants at the start, or lubricants got into the food, they would still be in the food at the point of consumption, but that's a relatively medium risk. Whereas pathogenic microorganisms, in terms of cooked sliced meats, are going to be an issue. So we would need to look at a specification of a slicing machine which controlled pathogens as a priority, but might also control material migration, lubricants, etc. So it's a format for how to undertake this hygienic design risk assessment. There's then the requirement for the manufacturer of the equipment to mitigate the hazards that we've identified through hygienic design. So there are some hygienic design criteria such as segregation and cleanability, and some of these, the aspects of these principles can then be applied as to whether they control cleaning agents, lubricants, allergens, material migration, which were exactly the hazards and the processes used that we identified earlier. So what do I need to do in terms of hygienic design to mitigate some of these hazards? There then needs to be some discussion, some debate between the user of the machine and the user requirement specification and the supplier of the machine and their supplier specifications. And this is the second part of the communication. So the first part was internal communication. This is now external communication, the communication between the user of the equipment and the supplier of that equipment. And again, at the moment we have different languages, and we're going to have to find a way to address this so that we talk the same language of mitigating hazards. So the user requirement specification has to talk about intended use, risk assessment, and what hazards have come from that risk assessment that need to be controlled. The supplier specification is built on the Machinery Safety Directive, which I think Nigel will talk about. And there is a requirement for an equipment manufacturer to create a technical file, describe the residual risks that haven't been controlled through hygienic design, and provide some cleaning instructions and maintenance requirements. But there's no common language here, and BRC 9 version 9 will apply to, on the left-hand side, to the user of the machine, but doesn't apply currently to the supplier of the machine. So how are we going to get that interaction? The next stage is a thought process on the installation of the equipment. So how are you going to undertake anything from drain blockage to installation of equipment to refurbishment, etc., particularly when production is carrying on in the facility. So there's a risk assessment of how you can do that without risk to the product. Prior to installation of equipment, we need to look at that equipment to see whether it's free of hazards, oils, chemicals, etc., that may be on it, or swarf or pests that come from the distribution chain. We're then going to install it, but if we install it in an incorrect way, we may add difficulties to particularly the cleaning of that equipment. If we install it too close to the ground or too close to a wall, etc. So there are risks in terms of installation. We then have to look at all of these risks that are still outstanding and mitigate them. This is the requirements of the food manufacturer. So some of the risks may be foreseen, and these would be described in the technical file of the equipment. And a classic one will be a blade guard. There is a revolving blade here. I need to protect the operator, therefore I'm going to put a guard in place. Okay, so I need then instructions of how to take that guard off so that I can then clean it. Eric talked about the installation of pumps in a way that they were undrainable. This also has implications on maintenance, and a pump that is installed in a direction that's undrainable may need to change the gaskets, the face gaskets, more frequently than a pump that is installed in the correct direction, simply because the gasket is under constant wear through absorption of liquids, etc. Some of the hazards may need to be controlled by cleaning, and there may be a risk assessment involved to determine the frequency of cleaning, and maybe the frequency of secondary cleaning, such as additional dismantling, based on the hazard and the risk of that hazard. So there are hazards that we know about that are residual hazards from the manufacturer. There are hazards that are created because what we asked for in the original specification was not matched by the delivery of the pump, and then any hazards that might be created during installation. All of those have got to be controlled by the food manufacturer's prerequisite or operational prerequisite programs. Finally, there is the concept of change management. And again, like any hazard system, if there's any changes to building equipment, raw materials, products, processes, etc., we may need to look again at the equipment to see whether it's still fit for its intended use. The outcomes of that might be it's fine, or we need to do a little bit of a change of our processes and procedures, or perhaps even some modifications to the equipment. There is a fear with the adoption of potentially these benchmarking requirements that auditors will come in and demand new equipment, but the reality of that is that it would be very rare. So that's the concept really of where we're going in terms of hygienic design risk management, and some of the principles that we're working on with the EHEDG to provide guidance for food manufacturers. And with that, I'll pass over to Nigel. Thank you.
Thanks, John. I have been invited to talk to you about the BRCGS 9 requirements regarding hygienic design and the specific clauses that relate to said hygienic design. Now, as you can notice, 4.6 says all production and product handling equipment shall be suitable for its intended purpose. This means existing equipment, not just new equipment. And obviously this has got a few manufacturers a little bit worried now, because obviously there's an awful lot of equipment out there in production areas that does not comply to hygienic design principles. Now, this has been brought in to tie in with the legislation rather than just go, oh, let's just throw this in for good measure, because that's definitely not the case. So clause 4.6, equipment, which is the first clause, says all production and product handling equipment shall be suitable for intended use. The next one, a brand new clause, says there shall be a documented purchase specification for any new equipment detailing what the site is going to use it for, and it must be include legislation or legislation references, requirements to food contact surfaces to meet legal requirements, as in equipment designed to come into contact with food. There must be no transmission of chemicals from product into food, details of its intended use. This also covers second-hand equipment. So basically, if you're planning on purchasing second-hand equipment, you may this will need to be reviewed in line with the legislation, and so you'll end up having a multidisciplinary team to go through the details of what have we used, what are we buying, does it comply, does it have a hygienic design certification, etc., etc. And when you are purchasing or sourcing new equipment, your supplier stroke manufacturer of said piece of equipment has to provide you with evidence that the equipment meets your requirements prior to its supply. I worked on a document for a company that they put together a pre-purchasing questionnaire that they were going to send out to all of their suppliers for equipment going forward, and ask for my inputs onto, you know, does it cover everything? Have we missed anything? They just about got about 90% of it right, and we added a few extra lines, and which they are now perfectly happy with, and which they will be using going forward. But they also said they were going to use it to assess their existing equipment on all of their sites across Europe. So they're fairly switched on when it comes to the requirements of what they require. 462, it's, as John has explained, design the equipment needs to be based on risk and to prevent product contamination. And so correct seals, impervious surfaces, decent welding, or hygienically designed, hygienically constructed welding, and where exposed product could otherwise result in foreign body microbiological allergen contamination of the food. You know, you want smooth surfaces, and as Eric said, you know, 0.4 microns as opposed to 0.8 microns would be a better surface for your stainless steel, because there's less areas for bugs to hide. And as John said, it's all about, you know, the risk of the equipment, and equipment that is in direct contact with food. And obviously, when you're looking at when you're looking for equipment, you've got 3 levels of you've got direct contact, you've got primary contact, secondary contact, and tertiary contact areas. So you've got to look at, is it all hygienically designed to be to meet what you require it to be? So, you know, it's going to stand on legs, but can you clean the legs that are in contact with the floor, which has the potential to have listeria over it? Is the framework hygienically designed? Do you have any horrible, hideous square ledges that you don't really want? You want round ledges, etc., etc. So it's not just the bit of the equipment that the food goes onto; it's the bits of the equipment that hold that elevated for the food to actually go along. So if you're looking at a conveyor belt, the legs, the framework, the rollers, they are all secondary stroke tertiary food contact surfaces, so they all have to be compliant with the guidelines and with the standard. 463, you have to carry out a risk-based commission. You must have a risk-based commissioning procedure prior to the installation of new equipment to site, and you shall have it inspected prior to delivery and prior to the start of its operation. I've been involved in a few PDIs on various bits of equipment back in my history, and going to the manufacturer to have a look at it and finding out things were not as they were requested, gave them enough time to be able to put them right. But if you don't have this commissioning procedure, you could find yourselves in some very hot water when it comes to auditors who are, you know, focusing on these new clauses. And you should also have to have a commissioning procedure, and you need to update it with other site procedures to bring it all together. And you need to make sure that where you put it is that you are able to clean it. It's all right having this all fancy piece of kit, but if you put it too close to a wall, you're not going to be able to clean it. If you put it over a drain, you can't clean the drain. I've been into enough factories to see that there are, sometimes you can't help but put it in the wrong place. But that's when, you know, it's a case of you've got to future-proof buildings when it comes to what the equipment you're putting in. We've been involved in a couple of projects for new builds and using the EHEDG guidelines for factory design as a benchmark to help our clients with their projects. 464, you should have a procedure to manage static equipment. That sounds like a bit of an oxymoron, but it's basically equipment that is designed not to be moved that you may move. So it's things that you generally think, okay, it might be something such as a mixer or an auger or a something that you would ideally leave in one place, but then you may have to move it. You have to make sure that food safety is managed and the integrity of the equipment is maintained when you are moving said static piece of equipment. You know, moving static equipment, as I said, it's a bit of an oxymoron, but you have to be in control of it. And stuff that you take out of surface, you have to store it and clean it in a manner that does not pose a risk to product. I've been in a number of factories where you go past pieces of equipment and somebody says, oh, that's the equipment graveyard. And it's just basically a store for miscellaneous pieces of equipment. And you go and have a closer look and they've not been cleaned, or if they have been cleaned, and now the food debris has disappeared, but they've now gathering dust. And then all of a sudden piece of equipment has to go back into production because they need it, but it hasn't been cleaned and it hasn't been stored. And it also said that they need to be cleaned and disinfected prior to use when you put them back into use. So if you have an equipment graveyard, it's the best thing is to do is clean, disinfect and cover and log what you have in your graveyard. It's a horrible term, but it's, you know, it's generally what people refer it to. Mobile equipment like pallet trucks, fork trucks, etc., need to be restricted to the areas that they used. You don't have an outside fork truck moving into the inside, and you don't have an inside fork truck moving to the outside. You also have to put a procedure in place for cleaning mobile equipment. Now, I wouldn't recommend turning a hose on a fork truck, but you have to make sure you have the appropriate cleaning procedure for your equipment, and you have to clean it and disinfect it prior to entering production. So if you're going to go out and buy a brand new pallet truck or a pump truck, you're going to have to clean it before it goes into production. And battery charging equipment shouldn't still be stored in open product areas. There are lots of factories I've been into where some battery charging equipment is actually in the packaging store or the goods in store, but occasionally the goods in store will have open products in because somebody has to go and take a sample. So it needs to be, the way you put it, it needs to be restricted. So you need to put it in a place where open product is not kept. So packaging stores are a good place, but then that brings you to the issue with you've got to clean everything that's been charged. It's going to go back into production before it goes back into production. So sometimes it's almost a bit of a catch-22 situation. But this new clause says, you cannot store it. You cannot have it in open product areas unless the batteries are fully sealed and maintenance free. Not all of those batteries are. Maintenance. There shall be planned preventative maintenance schedule or condition monitoring system, which includes all plant and mobile equipment. Also, it has to be reviewed after repairing any existing pieces of equipment. Sometimes it doesn't happen. I'm sorry to say, a piece of equipment gets repaired and then it's quick, we need to get it back into production, but there needs to be a sign-off from engineering to hygiene, from hygiene to production to say, we fixed it, we've cleaned it, you can have it now, thank you very much. And that has to be logged. It has to be recorded so you have evidence for your order to say, we have this procedure. Now, it's not just big equipment, it's little equipment. It's the stuff that Klipspringer and Vican and Salmon manufacture. Under clause 411, cleaning equipment shall be hygienically designed and fit for purpose. I've seen the wrong brushes used for the wrong bits of equipment, and I've seen the wrong squeegees used for the wrong surface. It may well be hygienically designed, but it's not fit for what it's being used for. So, and they need to be stored in a hygienic manner to prevent contamination. There used to be the big thing for, you've got to put your brush in a bucket of disinfectant, but if your brush is dirty and you're putting it in a bucket of disinfectant, all you're making is bug soup. So it's not the best thing to, going forward when you think of, oh yeah, we'll have that. No, we're not having that because it's wrong. You've also got housekeeping hygiene for high risk. Again, it has to be hygienically designed and fit for purpose and should be visibly distinctive and dedicated for the use in that area. I've been into lots of factories when you're going into umpteen different colors in different zones and you right, which is supposed to be here, but why have you these? And they give you an answer, and then you end up, well, why have you got umpteen different types of umpteen different colors? Oh, it's what we could get hold of. So as I mentioned, you can buy them from multiple sources, but you need to make sure that they are fit for purpose, hygienically designed, and food safe rather than food grade. That you're not going to transfer anything from the equipment onto the food and vice versa. Now, BRCGS hasn't done this in isolation. They haven't suddenly gone, oh, look, we'll throw in some hygienic design stuff just for the sheer hell of it. This has come in relation to guidelines and legislation. So 2006 42 Machinery Directive, surfaces of contact with foods for cosmetics and pharmaceutical products must be smooth and have neither edges or ridges or crevices and be easily cleaned and disinfected. So there's a direct link to what BRCGS has put in the standard to the European legislation. Even though we've left Europe, we are still governed by these directives. And the machinery must be designed and constructed in such a way that these materials can be cleaned before each use. As I said, we've not done it, and it's not been done in isolation. It's right, where can we put all of this together? Because not every engineering manager or operations manager or production manager or general manager knows of the legislation around what he or she needs for their factory. So it's basically a case of putting them in a standard where there is a connection to what the legislation says. And if you can't clean them directly on a day-to-day basis, you can use disposable parts. But there aren't many industries, or especially food, that use disposable parts, because disposable parts are expensive, and generally they're more expensive in the long run than stuff that you can clean and replace on a periodic basis. 852/2004, articles and fittings and equipment which food comes into contact to must be effectively cleaned and when necessarily disinfected and constructed out materials that are kept in good order, repair and condition. So again, there's another direct connection to the legislation. 1935/2004 covers materials and articles including active and intelligent materials. So that includes things like packaging, where your equipment or your packaging conveys a property onto the product, but mustn't endanger human health or bring about an unacceptable change in the composition of the food or deterioration in organoleptic properties. So again, it's putting everything from the stuff in the BRCGS, tying it to 1935/2004. And then you've got number 10/2008, silicons are no longer considered as plastics, but as elastomers under the CFR, and FDA has a comparable list. And 2023/2006 on good manufacturing for materials and articles intended to come in contact with food. So it's in that legislation as well. So there is, as I said, there's a very large tie-in with that in the legislation. And 1672/2, hygiene and cleanability, then your equipment must be resistant to corrosion, both as in chemical stresses, and non-toxic, or release nothing that's harmful to the product. So materials designed to come into contact with food safe, or food safe, or acceptable to the food product that you are manufacturing. You wouldn't want to have plasticizers or plastic products migrating into, say, an acid-based tomato sauce and things of that ilk. And they mustn't be absorbing, so they must be solid. So as it's going back to the hygienic equipment stuff, how many squeegees have you seen a sponge blade have a sponge blade, and people use them to move food and water? So you've ended up getting a wet spongy squeegee blade full of water and food debris and biological debris. So again, it's not the appropriate product, and it's not the appropriate type of product to use to do the job. Surfaces, they may not have crevices, which is what Eric has explained and John has explained as well. So there's a little bit of tie in there. No odors or dye stuffs or flavorings. Again, they must be impervious as well. Resistance to cracking, flaking. So you don't want them painted. And how many pieces of equipment have you seen painted in your times in food factories? Cleanable and disinfectable and smooth, less than or equal to 0.8 microns, as Eric pointed out, but that is not always a sufficient characteristic for smoothness of a surface. We all know under a microscope that smooth stainless steel looks like a plowed field. It's never perfectly 100%. It's never going to be smooth because of the way it's manufactured. And they've used these are some of the reference documents that have been used by the BRCGS committee when it was putting together the standards. So as Eric has pointed out, that there's in excess of 50 guideline documents out there at this present moment in time, and there are a number of them that are currently under review, or there is decision taken to review them, and invitations have gone out for persons who wish to be involved in the updating of these guidelines. Thank you very much. I will now hand you back to Debs. All yours, Debs.
Thank you very much, Nigel. And thank you to all our speakers. My camera seems to have decided not to work again.
Excellent. Not
very frustrating, guys. Never mind, you can still hear me. Anyway, just to say thank you very much for sharing all of your hygienic design knowledge with us today. What we would like to do now is to pick your brains a bit more in terms of hygienic design in our Q&A session. So actually, Nigel, I'm going to start with you. I've got a question here of cleaning of forklifts before entering production. Does that include forklifts going from low risk to outside?
Providing they stay in low risk, and they are a gas-powered forklift rather than a petrol-powered forklift, that would not necessarily be a requirement. But if you're going from low risk to high risk, that would be a requirement.
Great, thank you very much. I've got a question, I think, possibly for John. That might be, I think he would be the best person to answer this one. So John, if you're there, what is the guidance for management either continuing to use or discontinuing the use of equipment that doesn't comply with the specifications of the new clauses? So if you have that legacy piece of kit that is obviously not meeting the new clauses, should it be discontinued or removed from the area, or should it be I don't know, what should it be?
There is no clauses that apply to legacy equipment. So none of the clauses directly apply to legacy equipment. The question is, you should consider periodically whether your equipment is still fit for its intended purpose. And that's a risk assessment. You're asking, has anything changed? Has the product or the ingredients or the process or anything that you would classically look at when you updating your HACCP plan every year or so? And if nothing has changed, then the equipment is by definition still fit for purpose. If you are doing something, you're changing ingredients which contain more hazards, or your process is inherently more hazardous, then to ask the question, is the equipment still fit for purpose? And if so, can I manage that through procedures, cleaning, maintenance, etc.? It would be very, very unlikely that your equipment is not fit for purpose, and you would have to change it. You'd have had to drastically have changed what you're manufacturing and how you're manufacturing it for that to be the situation. So none of the current questions apply to legacy equipment. They apply to equipment that you're going to purchase new. But as part of your normal GMPs, you should ask the question, is my infrastructure, my equipment, process lines, buildings, etc. still fit for purpose? Okay, thank you. I think sticking with you, there's another question here about it's very hard, they're saying it's very hard to get sign off on new state-of-the-art equipment. And could poor design be countered with longer cleaning? I'm going to answer this one as a microbiologist. So the answer is yes and no.
Sitting on the fence, John.
Yes, theoretically, if the cleaning solution can get in contact with the microorganisms, extended cleaning, higher temperatures, higher concentrations, etc., will ultimately remove that contamination from the surface. If the cleaning chemistry will not contact the hazard. So if we've got a metal-to-metal joint with listeria in it, and the chemicals cannot penetrate into that metal-to-metal joint, then no matter how you change the cleaning and disinfection program, nothing will happen. And the only way that you can access that hazard is to distantly make the surfaces then visible to that cleaning agent. So yes, if the hazard is visible to the cleaning agents, no if it's not.
Okay, thank you. As a fellow microbiologist, I understand that. One last question, I think, and this one actually is quite an important. Well, it's kind of two in one, and I think this one's for Eric. So a lot of people are asking about the transition, but now that we're no longer in Europe, do we still have to comply with the EC regulations? Well, on food contact materials, presumably on the machinery directive, and also how can they become a member of EHEDG? So over to you, Eric.
Right, let's take that in two stages. First of all, does the legislation still apply to us now we're no longer in Europe? And the answer to that is yes. And it's for two reasons. One is because when the framework regulation 1935-2004 was brought out, there was a requirement on all member countries to establish those same principles in their own legislation. And the UK did. It embodied the framework regulation into Statutory Instrument 2619. And 2619 still exists, even though we're not in Europe. So Statutory Instrument 2619 says you must do this, you must do that in accordance with 1935-2004. So there's no excuse there, if you like. The machinery directive, which requires hygienic engineering, that is now part of Statutory Instrument 1597, 2008. So again, the principles are there. And those statutory instruments, almost word for word, use the terminology and the clauses and the requirements of their parent legislation in the EC. So that's one reason that we still abide by what appears to be legislation that was derived solely for Europe. It isn't. The other reason is because it's good sense. Designing equipment hygienically and using safe food contact materials has got to be seen as sensible. So yes. I can't see any responsible food manufacturer saying, let's not bother now we're not in Europe. So for both those reasons, the answer is yes. How does one approach the EHEDG? The answer is there will be an IFST set of slides, I think, being put onto the website from this webinar. And if you recall, the penultimate slide in my presentation gave the contact details for EHEDG, Nickel Institute, British Stainless Steel Association, Camden, etc. So please, it's right there how you can get a hold of the EHEDG UK. There's an email address. You pop that to me and I'll respond.
Great, thank you. So I suppose really, unfortunately, we've run out of time. So I think I'm just going to have to say thank you very much to Eric, John and Nigel for the information and the insight that they've shared today. Much appreciated. And I'm sure that we've shared some very valuable tips and hints to IFST members. Thank you to everyone for attending the webinar today. If we didn't manage to answer your question, please feel free to contact the presenters directly. The details, yes, fantastic, thank you. We've got the details on the screen now. We will share a recording of the webinar, including the Q&A session, to everyone who attended today via email. And it will also be on the IFST webinar website hub at ifst.org/webinars. Before you log off, please fill in our short survey, which will launch just after the end of this webinar. And thank you very much again to all our presenters and to everybody for attending today. Goodbye.
Thanks, Deb. Bye-bye.